The next method that we're going to see is the L'Hospital rule. So let us see what L'Hospital rule is. So if you have a limit of the form limit x tends to some number f of x by g of x, limit x tends to a, you have some function in the numerator by some function in the denominator. If the limit of this form, if the limit is of this form, some function in the numerator by some function in the denominator, and if on direct substitution, so you get either 0 by 0 or infinity by infinity form. So on direct substitution, if you get the indeterminate forms of the form 0 by 0 or infinity by infinity, then what you can do is this limit x tends to a fx by g of x will be same as limit x tends to a f dash of x by g dash of x. So limit x tends to a fx by g of x is equal to limit x tends to a f dash of x by g dash of x. So this statement is called the L'Hospital rule. So if you have limit x tends to a some function by some function, and on direct substitution, if you're getting indeterminate form of the form 0 by 0 or infinity by infinity, then what you can do is you can differentiate the numerator and differentiate the denominator separately and then find the limit again. So usually the indeterminacy will be cancelled after differentiation. So again, if on differentiation, again you just need to substitute x is equal to a in numerator and denominator. If the indeterminacy has been cancelled, so you can directly get the answer. So even after differentiation, if you are getting 0 by 0 or infinity by infinity, again you can use L'Hospital rule. You can differentiate it again and again, as long as you're getting these indeterminate forms. So this is a very useful rule where many problems can be, using which many problems can be solved. So let us try to see some examples where L'Hospital rule can be used. So let us look at this example. You're asked to find limit x tends to 0, x cos x plus sin x by x square plus tan x. So if you do the direct substitution, x is equal to 0. So the numerator is 0 into 1, 0 plus sin 0 is 0. So you're getting the numerator as 0. 0 square plus tan 0. 0 plus 0 is again 0. So you're getting 0 by 0 form. So what does L'Hospital rule say? If you're getting 0 by 0 form. So what you can do is I can write this limit as limit x tends to 0. The differentiation of numerator by differentiation of denominator. So what is the differentiation of numerator? X times minus sin x plus cos x plus cos x divided by the differentiation of denominator. X square's differentiation is 2x, tan x's differentiation is secant square x. So this limit will be exactly equal to this limit. Now, what is this limit? Again, you do the direct substitution. So 0, so this is 0, cos 0 is 1, cos 0 is 1, 0 plus 1 plus 1, 2 divided by x goes to 0, 2x goes to 0, secant square 0 is 1. So 2 by 1 is equal to 2. So as you can see, after differentiation, the indeterminacy has been neutralized. So before differentiation, you got an indeterminate form. So after differentiation, if you substitute x is equal to 0, you got a direct answer. So sometimes what happens is, in this stage also if you substitute, again you get 0 by 0 form. Then what you do? You can further differentiate it again. So again numerator differentiation by denominator differentiation. So in this way you can continue as long as you get a finite limit. Sometimes the difficulty in this L'Hopital rule is at each differentiation, sometimes the expressions that you get will become more and more complicated. So you have to decide whether to use L'Hopital rule or not, depending on the ease of the differentiation of functions. So let us look at more examples once you complete all the standard methods. So I hope you understand how to use L'Hopital rule.